Okay, let's unpack this. We've got a stack of sources here focused on, well, on specialized non-traditional mobility solutions.
For really challenging environments.
Exactly. And we're diving deep into one specific electric vehicle. It was originally engineered for maximum stealth and operational reliability, the Zero MMX motorcycle.
That's right. And for you, our listener, the mission today is to go, way beyond the spec sheet. This deep dive is an objective analysis of how an electric drivetrain just fundamentally changes a vehicle's tactical and logistical profile.
So we're breaking it all down.
All of it. The specifications, the very clear advantages, and the necessary trade-offs of this platform, which, by the way, was developed with U.S. Special Operations Command SOCOM.
To fill a very specific need, right?
That's
Deep,
correct.
low signature.
That was the requirement.
And we're tracking its evolution from the base Zero MX platform, which is a pretty rugged, lightweight motocross bike to start with, into this militarized MMX version. The whole design philosophy here is, well, it's fascinating.
It is.
It's all built around silence, minimal thermal signature, and just immediate rapid deployment. It's basically the ultimate tool for not getting caught.
And it really represents a philosophical shift, away from the heavy, large, and loud armored systems that have dominated military planning for decades.
Right, the big, noisy stuff.
The MMX is designed to exploit the gaps where those traditional vehicles are just. They're too slow, too bulky, or way too loud to operate effectively.
Okay, let's start with the hardware then. What's under the hood, so to speak?
Well, compared to a traditional gas bike, the Zero MMX uses their Z-Force electric powertrain. The key here, mechanically, is the direct drive gearing and an air-cooled motor.
So that's simplicity. No transmission, no clutch, no fluids to worry about.
Yeah.
That has to be a massive advantage in the field.
Oh, it's huge. That operational simplicity, it translates directly into mission reliability. When you remove all those complex mechanical systems, you're just removing points of failure.
And the power delivery.
It's instant. The rider doesn't waste any time shifting gears, which is critical in tight situations. The power is immense. 54 horsepower and 68 foot-pounds of torque.
And that torque figure is the key because it's available instantly.
Right.
Not just at high RPMs like a gas engine.
Exactly. Instantly. The kinetic capability is impressive. The bike has a top speed of 85 miles per hour, though your sustained cruising speed is probably closer to 70.
Okay.
And to give you a real-world comparison, the original, lighter Zero X model could hit 30 miles an hour from a dead stop in under 2 seconds.
Wow. So you're getting just instantaneous silent acceleration.
Precisely. But the architecture is where we see that first major trade-off.
Okay.
The MMX is exceptionally light and 275 pounds. But the total payload capacity, including the rider, is only 355 pounds.
So once you account for a fully kitted out operator, you're left with, what, maybe 100 pounds for gear?
Roughly, yeah.
Yeah.
About 100 pounds for gear, weapons, and this is the important part, spare battery packs. You're trading capacity for that low weight.
And the power source itself, it's modular, right? The MMX runs on 2 Z-Force lithium-ion packs.
2 of them, yeah.
Right.
Each one is 3.6 kilowatters. And there's an interesting note in the sources about the voltage.
What's that?
It's only 50 volts. And that's important because most modern EVs, cars, trucks, they run on systems from 400 to 800 volts. 50 volts is considered a safe low voltage. It's not high enough to cause an electrical shock.
Which makes handling them in the field, swapping them out, much safer for the operator.
Significantly safer. And that rapid change capability is really the innovation here. It's a hot swappable system. It's the closest thing to refilling a gas tank that an electric vehicle can offer right now.
Oh, yeah.
You can pull the packs out and replace them in under a minute, no matter what their charge state is.
So you're not charging in the field, you're just replacing.
That's the idea. It fundamentally changes the logistics.
But let's get the big limitation out on the table because it seems to govern the entire platform range versus terrain.
It really does.
What are the practical limits on this thing?
Okay, so if you're on, say, mild terrain-paved roads, smooth trails, you might see around 80 miles. But the sources are starkly clear. When you're in harsh conditions, deep sand, steep climbs, that kind of motocross terrain, the energy drain is catastrophic.
How bad is catastrophic?
Reports say the battery can be totally depleted in as little as 20 minutes of continuous hard use.
20 minutes. That's not a small reduction. That's a mission-critical constraint.
It is. And if your operational window is measured in minutes, you have to rethink everything. Recharging, even fast charging, takes time.
So how do they handle that?
Well, the MMX is designed for flexibility. With a quick charge accessory, you can get the time down to about an hour. And crucially, it interfaces with the CHAdeMO accessory.
CHAdeMO. That's a pretty common standard, isn't it?
Very. It's a widely adopted DC fast charging standard. So this means that if you're operating near infrastructure, these tactical bikes can literally tap into the same civilian charging networks that thousands of commercial EVs use.
So if the big limitation is range, the huge advantage has to be stealth. This electric platform gives you two advantages that, internal combustion engines just can't compete with. Acoustic and thermal. Let's start with the silence.
When the MMX is stopped, it is absolutely completely silent. When it's running, all you hear is this light electric whine from the motor and the sound of the tires on the ground. It generates about 55 decibels.
55 decibels. To put that in context for someone listening, that's often less than the ambient sound inside an armored vehicle. It's quieter than light rain.
For sure. And a standard gasoline dirt bike, by comparison, is screaming at 113 decibels. You can hear that miles away.
Yeah.
That massive drop in sound is why specialized units have adopted it. The LAPD, for instance, uses them for patrolling large, sensitive parks where noise pollution is a huge concern.
But the thermal advantage?
Yeah.
In a world full of thermal optics, that might be even bigger?
I think it is. Think about it. An internal combustion engine gets so hot it would literally glow if you looked at it through an IR camera.
Right. It's a beacon.
It is. The electric Z-Force motor, because it's so much more efficient, it only produces a very minor heat signature. This makes the bike practically invisible to thermal optics. That's a game changer for night ops.
And that covert capability is built into the whole design, isn't it? It goes beyond just the motor.
It does. You see it in the MMX's ability to handle wet operations. For one, it's designed for up to 1 meter of submersion.
Wow.
And for missions in total darkness, the bike has integrated wiring for front and rear IR systems and switchable headlights for nighttime stealth.
So what about reliability? Is the benefit just stealth, or is there a maintenance advantage too?
It's immense. The sealed motor gets rid of almost all routine maintenance. No oil changes, no clutch adjustments, no spark plugs, no carbs.
So it's always ready to go.
Instantly, even in extreme conditions.
No.
And there's a subtle tactical point here, too. There's no fire risk if you drop the bike in dry foliage, which is a major headache with hot gas engines.
Okay, so let's talk about where this vehicle actually fits. The sources call it a capability gap filler. You have your huge armored vehicles like the JLTV, but they're limited by their size and the terrain.
Precisely. And in places like a dense jungle canopy, in the Pacific Theater, those JLTVs struggle and drone vision gets blocked. The MMX gives you that agility.
And real units are using these.
Oh, yeah. U.S. Marine Recon Units, SOCOM, they've integrated the MMX for specific roles: reconnaissance, screening, which is basically providing early warning for a larger force, and for rapid direct action raids.
We've even seen reports of similar bikes being used to strap, say, anti-tank missiles on the back in some conflicts.
And that just highlights its utility as a rapid asymmetric platform.
Yeah.
But the main use case for U.S. forces is about creating tactical offset.
Offset.
Yeah, so mobility teams will use a larger vehicle like a ULTV to get close. Then they'll stash it and push out further on the quiet electric bikes. It maximizes the distance between their staging area and the final objective.
So they get in and out faster and quieter.
Exactly, before proceeding on foot for the final observation.
And that 275-pound weight. That seems like a logistical masterstroke for air mobility.
It is arguably its greatest asset outside of stealth. That low weight means you can transport it on almost any heavy-lift aircraft. CH-53s, Ospreys, Chinooks.
You can even airdrop it from a C-130.
Right. The logistics become incredibly simple. The vehicle can go wherever the troops go, instantly.
And it works with ground vehicles, too, extending its range.
Correct. They have mounting brackets, so you can just attach the bikes to the front or back of a larger ULTV, like a Polaris MRZR.
So the bike becomes a scout.
A highly mobile scout, yeah. The main vehicle handles the heavy lifting spares, fuel for itself, extra battery packs, while the bikes go scout ahead.
And the simple operation, no gears, no clutch. That must speed up training.
That's the theory. But here's a word of caution from the sources. That simplicity comes with its own technical difficulty.
How so?
Marines noted that the instantaneous torque delivery is super sensitive. They called it all or nothing. A seasoned gas bike rider has to completely adjust how they ride, and it makes precise low-speed maneuvers really challenging if you're not trained for it.
Okay, so let's synthesize those limitations. We have to be objective about the trade-offs here. The first big one seems to be energy density. the weight penalty.
Yeah, batteries are dense. They're much heavier for the equivalent energy output than diesel or gas. That high weight, all concentrated in the battery packs, is why the payload is so restricted.
So you're always making a choice.
Always. Do I carry an extra weapon system or do I carry an extra battery pack to make sure I get home?
And that's made worse by the environment. The range dropping to 20 minutes in harsh terrain, that changes everything about how you plan a mission.
It creates a severe logistical choke point. And on top of that, batteries are subject to failure or reduced performance in extreme temperatures, hot or cold.
Which brings us to the charging vulnerability. If you've achieved stealth, how does the need to recharge compromise all of that?
It totally exposes you. Recharging takes way longer than refueling. You're a sitting duck. And while some have experimented with solar panels for recharging, that means you have to stand out in the open in the daytime with a clear view of the sky.
Which is the exact opposite of a covert mission.
The total opposite.
And what about the operators themselves, the Marines who tested them? What other feedback did they have?
Well, they consistently cited that all or nothing torque control as a difficulty. They also flagged some specific failures, like the engine cutting off completely if the bike is dropped.
And for night ops?
Critically, for night operations, they noted the LED battery display shuts off when you deactivate the running lights for stealth.
So you can't see how much battery you have left when you're trying to be sneaky.
Exactly. You're flying blind, which is the last thing you want.
It sounds like the software interface needed more work to match the hardware's stealth profile. So what about alternatives? DARPA had that hybrid Silent Hawk project.
Right. And it comes down to a fundamental debate: complexity versus reliability. The Silent Hawk was a hybrid, so it used a small gas engine to charge the battery or even propel the bike. It guaranteed your range.
What?
But Zero's CEO argued the hybrid system was just overly complex. It adds a gas tank, filters, plugs. It increases the maintenance workload. And Silent Hawk was 75 pounds heavier.
So for Zero, the simple, maintenance-free, full electric stealth was worth the range trade-off.
They decided it was tactically superior, yes.
And finally, the cost. This can't be cheap.
It's significant. The military specs and modular design drive the cost way up. The battery packs alone are a huge investment. An early replacement price was cited at almost $3,000.
Oh, for one pack.
For one pack, with an expected lifespan of 5 or 6 years. So units have to budget for battery replacement just like any other scheduled maintenance.
So what does this all mean then? The Zero MMX. It's a case study in high-stakes EV tech. It makes huge sacrifices, range, robustness in some cases, for these critical tactical advantages.
Right. Near absolute silence, a negligible heat signature, and much simpler logistics.
We've seen that in these very specialized covert roles, the ability to be stealthy is prioritized over almost everything else, over sheer endurance or all-terrain performance.
And that balance, that's what defines the precise capability gap these bikes are so uniquely suited to fill.
We hope this analysis gives you a curated and nuanced understanding of how this electric drive technology is quietly reshaping field operations. Thanks for joining us for this deep dive.
And consider this. If a vehicle's ability to move without being seen or heard becomes the ultimate operational priority, how might future innovations solve that energy density problem? The weight and the range, without resorting to complex hybrids? Will the next generation of silent mobility rely on exotic power sources or just on, a whole new kind of battery chemistry?